So we're live. Hello everyone to this week's Tech Excellence session. My name is Oliver, and as you probably already know, our vision is to raise the bar of technical excellence across the world. And who are we? Well, on one hand, we have Valentina, who is our founder and organizer of Tech Excellence. But there's also Daniel, Alina, and I, who are also co-organizers and co-hosts and also hosts of these Tech Excellence sessions. And last year, we already had great speakers and great talks, but we will, of course, continue also in this year with even better presentations and speakers. You can follow us on the common social media like Meetup, YouTube, LinkedIn, Twitter, GitHub, and also Discord, where we can discuss with other like-minded software crafters about tech excellence and software craftsmanship topics. Our sponsor is Optimum and our partner is QE Unit. And for today, we're happy to be joined by Janis Orlovs. Janis is a PlatformOps and DevOps consultant at cwise.eu with more than 13 years of experience in the field. And today he will give us insights into code testing and validation in Terraform, which he has learned during the last 5 years working with it on a daily basis. But before I hand over the mic, I want to remind the audience that you are encouraged to write comments, observations, and questions down in the comment section below, and that we will make room for them after Janis' talk. But now I hand over to Janis. So Janis, the stage is yours.
Hello, everybody. Nice to see you. Let me share my screen, and we can proceed with starting. Starting. Okay, enter screen. So okay, share view history. View. Just a second. Always. So yeah, today's topic is testing with Terraform. My name is Janis Orlovs. I have been in DevOps since 2013, and for the last 6 years, I'm founder and CTO of company cwise. What we do, we mainly focus on DevOps and platform ops. I would say we started platform ops before it was cool, and what I really like is to build good developer experiences and testing code, and being effective with code development is definitely one of the first things what we need to do today. So okay, next. So yeah. Today's agenda is focused on infrastructure as a code testing with Terraform. I will do the brief introduction. What is Terraform? Where we can use it, but this is definitely not one-on-one talk. This is a little bit more intermediate or even advanced. So yeah, that there could be some gaps. What I will not cover with the basic part. Yeah, but I will start with the general and how it will go. I have prepared presentation. I will do live coding demos. I have prepared three live coding demos, and in the end we will have QA session. So I think let's proceed. So first words about where we are with infrastructure as a code testing. So infrastructure as a code have been major stuff for more than I don't remember how many years, but it was one of the things and topics what I started my DevOps journey because I like to automate stuff. But in the end, it always ended with the problem that you have to. It was time consuming because there was lacking of testing and or being even effective. The thing about the infrastructure as a code, it's the testing itself was a little bit underdeveloped. It's not so efficient and not so fast as general unit testing for much more popular languages like Java, Python, and so on. But it's getting better. The few other questions, the assertions and definitions, what to test are pretty fuzzy. Unit test takes much more time than let's say standard unit test just takes for general purpose language. If it's well written, it just takes milliseconds. But for example, creating some Kubernetes cluster can take up to 20 minutes. So it's pretty painful to test. And also infrastructure as a code testing is still significantly focused on syntax testing, less on functional testing part. Why this talk is about Terraform? Terraform is one of the most popular infrastructures as a code tool, and it's developed by HashiCorp since 2014. The general why it's so popular lately, because it offers standard workflow for any cloud provider, any solution. So it's pluggable architecture. You can have you have got Terraform itself, and then you have got providers and modules. What are the like for example, AWS is not implemented in core of Terraform, but as add-on and so on. You can do broad variety of tasks with Terraform, starting from major cloud providers, ending with you can even send physical mail through the Terraform code that is supported for one US mail provider. Yeah. And cool thing about Terraform, it is very popular, and it have got pretty broad ecosystem. What has got, and definitely already mentioned the thing is why it's so popular. It works well out of the box, and it offers consistent experience across all providers, even if the provider syntax can be different, but the stages how you develop and apply code is always the same. Speaking about Terraform testing tools ecosystem and testing tools and patterns ecosystem, I would put everything in three big boxes: linting tools, testing tools, and security and compliance tools. So there is a lot of this is pretty my opinionated definition how it works, but there is a lot of currently the most hottest topic is in the security and compliance testing part. There is a lot of new things happening in the same time, and one of the coolest thing is Open Policy Agent, which is being developed rapidly, and I would definitely say that it's gonna be and it's not limited just to Terraform, but it's supporting almost all cloud native stuff. And then there is a lot of third party and third party commercial, third party open source tools. But the good thing is that Terraform is also HashiCorp itself is working on making testing native for Terraform, because testing and linting for Terraform, because most of the stuff what we see here is either partly implement things or not so well. Yeah, that's the next thing. So what we will gonna do today, we will do deployment of really simple infrastructure. We will have virtual private. We will deploy virtual private cloud in virtual private network into the Google Cloud. We will deploy simple virtual machine and storage backend. All stuff can be accessed through this link. These are public repos. You can check now or you can check later. But yeah. So how the Terraform development workflow looks like in, let's say, enterprise setup. When you develop code, when you develop code, you develop such thing as Terraform modules. These are reusable components then you from these reusable resources compose environment config. Then you do the plan stage, either on your machine or on cicd, and do the apply stage. But in the few years ago, it was really common to do from the to development full cycle of development from your developer machine. But now it's already getting better and better, doing everything through CI/CD systems, and I think it's the right way. And let's proceed to first of the practice. Our technique what I use for testing on daily basis is code linting and with pre-commit hooks and TFLint. This is one of the easiest part how to improve your Terraform coding experience from many aspects. This is being developed as open source module for and it bases on pre-commit technology, and this is basically Git hooks. It can there is a broad spectrum of tasks what you can do with this, starting from really simple validating code and formatting code, ending with the security tests, with document generation and so on. And this is like absolute easiest thing how to improve your Terraform coding experience and get it like up to speed. So let's proceed to the demo. So I have prepared, if we go back, I have prepared these two modules, what we will these two repos. One of them will represent module code, second will represent environment code. I'm going to the module code. And this is like a module, yeah. And I have got already checked out this, so I will proceed with the module part. Sorry. Yeah. As you see, there is some code already written. Code itself, what it does, it creates service account for Google. It generates random string. It creates a virtual machine with some variables, and it creates a Google storage bucket. So let's start with as you see, the code is not very well. It's not very well formatted. There is different formatting types, formatting, and so on. So let's start with the easiest part, with the pre-commit. I have already installed on my machine pre-commit. and it's available as open source part, and you just need to install on your working machine. And there is pre-commit configuration, what I have commented out, but I will enable it. A second. I will enable the different tasks. One of the first tasks is Terraform formatting. For Terraform validate, Terraform generating docs part. Let's see how it works. Just a second. So adding test commit. Never write so bad test commit message. So what we do, we need to initialize, try commit, install. So and it's already there. So if I will do some change now, let's say I'm doing some. Let's say I will add one more variable. Yeah, that's there. So let's try to commit. Adding variable. And as you will gonna see, what's going on. It's in the background. It's trying to do the commit. Commit will fail. Why it's gonna fail? Because when you work with the Terraform with some tasks, you need to also do the init, and we can see that there is something wrong with our code. Okay, we can do it. We can do it. It's code linter already deployed. What already happened? We have now fully generated README file based on our inputs, outputs from the variables. We have got already formatted our code in much more nicer way. We also need to do the it will do the dummy initialization. And if we will click one more time, because I have got enabled run git hooks, and it's gonna be so, and it passed validation. If, for example, I will do let's say, if I remember, I'll remove this, and I try to simulate problem, it will not gonna allow me commit code inside. Why? Because its code is invalid. And if we have got configured TFLint, it's also does the integration. There is also configured rules from different cloud providers, different things. So you can also do the validation not just on code side itself, but also you can do it on a much more deeper level. For example, for cloud provider. And if I will try to do the commit now with the wrong instance type, it will check against the against the Google Cloud rules, and the message will be really simple, like your machine type is not valid. And there's that's the first trick what I use on daily basis for improving code and testing code. So now let's go back to the next part. As I told, this is really easy part, and where we can use it. We can use it on module part, and we can use also on demo part, on environment parts. This makes much more easier. So Next technique what I'm using efficiently to make efficiently is example pattern. So when you are developing your own Terraform modules, please always include golden path for your uh, for those who will gonna use this module. This is not machine centric stuff, but this is for user centric stuff. Uh, it's difficulty to do it is from easy to medium. Treat it as hello world or getting started in 5 minutes. As I told, main audience for this technique is engineers. One of the techniques, what I would say that avoid building examples based on many other modules, and this is like to keep it simple and keep it simple. Yeah. I have got already prepared also this part. So yeah, there is submodule or part which calls the module what we are already developed. There is some additional resources created, and as I already mentioned, please avoid using depending on different modules to make it simple and make it understandable. Because if you will go into like for example public modules to create subnetwork and so on, it adds additional complexity. In this way, you can show the module usage in as much as easy way as possible, and to make it understandable for end users of this. If we will do the apply and so on, it's gonna make it. It's gonna build this simple machine. If we'll go into the and it's gonna do the whole stuff what's needed to create. It's gonna take some time. Yes, sir. So okay. Where we mostly use this example pattern, we are mostly using on module side, because in environment code it doesn't make sense, and it's quite bad to make it to make it much more easier to understand modules what you have developed. Also enable testing, enable changing. This is a great way how to make your life easier. Yeah, that was already demo. Next part is Terratest. It is testing framework from Groundworks, one of the additional one of the biggest third-party Terraform ecosystem developers. It's testing framework written and based on Go, so you can do the proper unit testing with Terraform based on this. This is example pattern on steroids. And you can include all the assertions and so on what you need to do. But I don't have prepared for this. Demo. Where it fits very well. It fits perfectly with the module code. And yeah, that's where you can where you can use it. Okay, and the last, not the least part, is to use Conftest, which is part of the Open Policy Agent. Open Policy Agent is cloud native, part of the Cloud Native Foundation's tooling. It's focused on building compliant environments and compliant systems based on shifting security left. I will show some stuff. Yeah. There is a lot of tools around, but I kind of like Conftest because it's very simple and very well integrates with the workflow, with the development workflow. You can write different types of rules and tests based on the Rego language. So the learning curve is a little bit steep, and this is where we mostly can use Conftest or Open Policy Agent is on the environment codes, environment part. So okay, I will show the demo now. So I have prepared some environment which consists from virtual cloud, which is made from the official Terraform module from Google, which creates the subnet itself, some virtual cloud subnet, and then we have got our own developed module, what we are using, what we just saw. Here it is. Creating all the stuff. So let's try to create it. And the environments. We will initialize code. And we will run Terraform plan. And it says what it says. It says that we're gonna create a lot of resources. We will gonna create storage bucket. We will gonna create instance. We will gonna create network. We will gonna create buckets and so on. So what we can do now? So we will do the Terraform plan one more time, but we will save JSON output. Okay, and that's and what we can do now, we can run the configuration test based, and we will see that there is 2 tests passed and 2 unknowns failed. What's in our tests? Basically, the possible, as I mentioned, the whole Open Policy Agent language is based on Rego. So what's in here? Like we have got main package where we do the input based from our JSON files, what we have got created from the Terraform test, and what this policy does. It checks allowed sources where we can download our Terraform modules. When this is cool, for example, when you have got when you have got some older Terraform modules, what you don't want to allow any more use, you can set up in your cicd system that everybody uses, for example, latest version of module, or don't use latest version module, and this is how you can enforce. Second policy is to check with either Google storage class, either bucket storage class is standard, and also this is piping from to the input files what we are passing to them. For example, if we will change now to something really random, it's gonna will say that test is failing, and you will not be getting working stuff. And this is the really nice way how to ensure few things: improve the compliance, help your security teams, and get in line. For example, some like things like enforced tagging, enforced labels on resource, enforced not creating public stuff or creating public stuff, and that's Let's go back to the demo. Yep. So I have shown my presentation. So do you have got questions?
Thank you, Janis. Sorry, I was muted. Thanks a lot for the presentation. Let's see if we already have some comments. So the first question we have is from Tester Testman. Could you please show a code example that covers a test case? So I think you, if I'm not mistaken, you jumped over the Terratest unit.
Yeah, I jumped
right?
over the Terratest. Yeah, but it's yeah, I don't have code example for Terratest, but but in general, it's like it just do the part of. Oh, sorry, I will just kill my remove from screens. Yeah,
or maybe you could even show if there's any useful websites or links where someone can maybe find examples.
Yeah, I always that's what we can show. That's basically. Do you see my screen? Yeah. So just a second. Yeah. Go. Let's go to the. Yeah, basically with the simplest part is like hello input output, hello output, hello world, and here is test case.
Can you increase the size a little bit?
Yeah, I think that this is good so that everyone this is useful that you're doing a short intro of that page, since some people might want to try this.
Yeah.
Maybe with Zoom, if you could zoom into the page or something.
Okay, here it is, the simplest possible test case. What it does, it's a
little bit too small. Maybe increase the size just a little bit.
Just
or zooming in the browser if possible.
Just a little bit, kind of.
Or I think we can proceed with this font. Maybe you could walk us through, explain that code. What does it mean, like from start to bottom? Since we have, there's a mixed audience, so some people might be completely new. Feel free to explain this also, like at the beginner level as well.
Yeah.
We have enough time, so you can really start from the beginning.
Yeah.
So let's go to the examples. And the basic version was like sorry. Oh, a little bit. Yeah. Hello world. So we have really simple stuff. What it does, it doesn't create any resources. It just prints out hello world part. Like,
where does it print it out?
It will print out into the, if you will do Terraform apply, it will gonna show into the output of console hello world. And in this case, what's happening is when we are running the Terraform test case, the function Terraform test case, we assert that the output value will be hello world, and this is basic. This is try and catch logic to deliver the stuff. Yeah, and what happens? The good thing with the Terratest, it's does the undeploying part undeploying part after the test either is failed or passed. So you don't have any resources stayed into the somewhere generating you costs on money. That's common problem with this unautomated testing, like for example pattern.
So do you inject somehow some dependencies, so that, I mean, similar to unit tests like you would do in programming languages, so that you don't
that's basic. This is fully Golang party, but if you use PyTest for Python, there is also support in Python to do the Terraform testing with all the niceties, what you need or you don't need. Basically, almost all the Ruby have got kitchen support. There is for Terraform testing. For Golang, there is Terratest. Actually, for Golang, there is also something from Google, but it's more focused on Google Cloud part. But this part is for almost all major cloud providers supported.
Yeah, it's good to see this, and maybe if we could just walk through these. So you mentioned the part about Terraform destroy. Is that the part which does essentially cleanup of the resources?
Yep.
At the end.
So what we can let me show you. What's gonna happen when I would create here? It's will tell what I want to create. If I will run Terraform apply, it will create the resources. And yes, and if I then after the resources are created, they are start generating most cases some costs. So what we need to do after tests, we need to delete it, and these automated testing tools are doing the full life cycle, not just creating but also deleting and cleaning up the resources that there is nothing generating costs.
Okay, this is a good overview, and maybe I want to add a comment for the audience. I guess the general form of what is being shown here is in tests where we have actual resources that are being used, how we have set up and then tear down to essentially clean up any resources. So this was good that we got to see this, and maybe you could. Okay, it's creating. Okay, I guess you can show it, and then I have some other questions.
Well, let's delete it.
Okay.
Otherwise we forgot to running virtual machines and generating that, and that's one of the main problems with the. Okay, this was really fast, but one of the main problems with the infrastructure is the code testing. It takes quite a long time. It's not like running some unit unit test. Like this is relatively slow, taking account that we are just completing one scenario on this. But that's
I
why
see this. Yeah, I think I like how you explained it, and to me this looks similar like integration testing. For example, if we are integration testing with a database, we may need to, let's say, to spin up a database instance, let's say via Docker, do some tests, and then later it's essentially going to be torn down. So it, I guess, reminds me of that part. Okay.
yeah,
Thanks for
yeah, but it's like it's not like that. Okay, integration testing itself, yeah, it's like Docker made the things much more faster and much more efficient. But like general infrastructure, the code testing is like something moment before Docker. What was it? It's something like moment before Docker came around for general purpose resources, because creating resource takes some time coming up, while it becomes ready, and also that also. But I, as I mentioned before earlier, that I think this year is gonna be one of the breakthrough years for the infrastructure, the code testing, because there is a lot of movement on this, what's happening, and the tooling is getting much better and better around it, and much more bigger traction, and everybody's, and yeah, that's the general premises what I have got.
Yeah. I like everything that you showed up to now, and I mean, people like seeing code demos. So it was nice how you showed us that Hello World example. Is there any other example on that website which is which shows an example of a resource being created, and like what do you test, like after a resource is created, what are some things that can be tested, something where there's maybe some assertions, if you know anything like that?
You can test there is whole library.
Yeah.
Like you can
Maybe you can open up any other, like choose something random and walk through it.
let's see very simple part. For example, AWS S3 bucket creation. It creates the AWS 3 bucket. It's sorry, sorry. It asserts that the bucket is in correct region, the correct bucket ID. We have got enabled that. It expects that we have got enabled bucket versioning. It expects that the correct logging is set up, and so on. Basically, you can do all the aspects what you can get out from API when creating something. You can do it. You can get out. You can do as testing assertion, and you also can do like such stuff, like for example, checking connectivity between created instances with some fuzzy generated traffic. Like for example, SSH. Can you SSH onto the instance? You can do it, and you can do it and in this way you can get much better quality out of the general code what you have written and passing to your customers and your peers and so on. That's
Yeah,
what
this is pretty very useful. I mean, even in this example here with the S3, so essentially we've seen that we can create an S3 bucket, and then we can test certain characteristics such as the policies or logging target or something like that.
Yeah,
which is quite
you can do it basically all the stuff what like as I mentioned, like you can test everything what's being offered by API part, and also you can get some custom stuff, like for example some HTTP requests, some general connectivity, and making sure that you ship code and ship your solution what is really working and will not generate you any more headaches. Yep.
yeah. And
So
one more question
can you
again
okay.
about code. Which languages are supported? So you mentioned Go, you mentioned Python. Are there any others,
Yeah,
or it's based
let's go back to the part of the ecosystem. Yeah. Okay, we'll review. So what differs on it differs on sorry, what yeah. For example, Terratest is fully Golang stuff. So if you are developing something in Golang, then it's gonna be very simple. Terraform kitchens, InSpec and AirSpec and AWS spec, which is a little bit not little bit, but it's specified to AWS. It's everything is Ruby part. Then there is here is not mentioned, but you have got also libraries supported for PyTest, and these are three most popular programming languages what are besides Bash for DevOps engineers. The higher level languages, like if you want to go into the little bit different languages like Node, like Java, like Rust and so on, then probably the option then is to use Pulumi as infrastructure as a code tool, but reuse Terraform modules. There is not all the languages have got proper support for testing Terraform, but the most popular languages for like DevOps folks, like then there is support. Then there is Terratest for Golang, there is Kitchens for the Ruby or Ruby-ish, and PyTest for Python.
Wow. And which of these languages are you using? Which of these do you see as essentially being dominantly used?
I essentially mostly I used as something from Kitchens, because there is good integration with chef part, and this part with the whole the kitchen part is mostly, but currently the most interesting development what happens is around the Conftest, open policy agent, and all this stuff what happens in Rego and Rego part and open policy. Why? Because it's because there's always have been pain for security teams to shift security left, and this is great opportunity to do it right now. Yeah. And if you look currently around the trends, then open policy is now covering more and more stuff, and there is like almost each week some new tool coming out for what you can use and make your workflow better on this.
So would you say that the stuff you can test in Terratest you can also test in Conftest and the other way around, or are they completely separate? One for compliance and the other one for actually testing?
Conftest is more focused on compliance and validating the in like syntax validating and validations and but it doesn't test live in normal way. It doesn't test the live. It does test the live system. It just shows the like here you go this string and that string and we checking and it doesn't follow the our policy. But Terratest, PyTest, kitchens are more like real unit testing tools. Like it creates resource, destroys resource. It checks resource against different things. You can check either like more syntax focused, or you can check or like real functionality testing. Do that.
Cool. I think we also have a question or from Daniel. I wonder if it is possible to drive the infrastructure design by using test-driven development. Maybe Terratest provides some quick tests to be used with TDD. Have you as a first? Yeah.
For that particular case is actually I'm not so fancy guy, so I really much extensively use examples and example patterns, and that's basically the for simpler projects you can use it even but yeah, you can. In the end, it's code, and it just sometimes let's say previously it was much more painful, but lately doing test-driven development on infrastructure is not just easy, but it's actually super easy, because the start times are much lower. If you are into serverless world, then not doing TDD is like you are not doing things right, because okay, with the classical virtual machines and so on, like there is a little bit more place for error, but with the serverless part, you like it's so efficient, and it can the things can go so wrong so fast. So I definitely say it's not a way, but it's the way on especially in serverless part.
And I assume it can cost so much if you do it wrong. So probably you want to start.
Everything can cost a lot if you do it wrong,
Yeah,
but there is like I would say there is section on Hacker News where someone is complaining that how much serverless cost for them, but it's also true for every other method solution. If you don't test it, then it can be pretty costly. But it's not like yeah, it's TDD is just it should become norm into the also infrastructure part, and tooling is getting better, and I would encourage to test it out, pick something from this list, and just do the work, and everybody will be much more happier with the results and with the output artifacts what's coming out, and yeah.
Can I ask you again the example pattern? This was quite fast for me. I didn't quite catch that. How that actually work? Could you explain that maybe once again? I think you did you show a demo on that?
Yeah. Okay. Example pattern. Yeah. So example pattern is what I yeah. The example pattern is a pattern where I show when I have developed module for example for you, the capabilities of module in the simplest, easiest way possible. And this includes like if I will run the EFP, I will copy one configuration file to do not. Okay, just a second. I will copy vars file that I don't have to input something into here. Okay. So if I will run here, for example, you just pulled the module and you want to see how it works. This is the 5 minutes getting started way. For example, in this case, it just will create the virtual machine. And okay, I will remove. Yeah, that's not needed. That needed, but basically, it just like when you. This is good. This is the easiest one of the without any fancy tools. Just using the Terraform. Just using Terraform built-in functionalities. Just come here. Just try Terraform apply. Terraform init. That's already here. Terraform apply based on your infrastructure config, and you get like simplest possible solution what you can get, like with the things. What I already like here is like basic module part. What comes with all possible or impossible solutions, but what you can do it with this. But these example patterns are either the most common used scenarios what you can use for yourself for testing, or you can use for showing the product. But it's like bare minimum what's needed to run. I would encourage to avoid relying on other modules while demoing, because using other modules is not bad, but it adds complexity and makes a little bit harder to understand what's happening. So like all the and here you get like already working virtual machine. And for example, if you have got other common case, because when you develop Terraform modules, there is an option to use also submodules. For example, you can create like, I don't know, simple virtual machine. You can create like auto scaling route of but you still need these examples to show people around what is possible and how to get it running out and running. And when you have got and when you have done it, just do the deletion of that.
So this is a bit like a built-in tutorial.
This is built-in tutorial, but not everybody does. But where it does, it's really nice way for example, if you are developing Terraform modules internally, it's really nice for team to have it. Also, you can test it out yourself, and if you cannot test it here, for example, simple or integrated infrastructure, you probably have got some this without that. This is also like some semi-manual, semi-automatic testing approach and development approach being effective. That's yep. And now we just created instance. We are deleting instances. As I told, it's much more. It's kind of longer than regular unit tests, but it's still like in reasonable time frames.
And are there like best practices for these example patterns? I mean, do it always like that, or so that people get quickly into those modules? And
yeah, that's definitely part of the best practices. There is also very good site called Terraform best practices. Here is like all the best things what you can do. You can get code styling, naming conventions. Yeah, that's all there. This is very well, kind of very well supported and well loved language. So it's really easy to start, really easy to work with, and there's a lot of options how it's extended and how you can be efficient and how you can test your coding part. And like basically there is like bunch load of supporting languages and so on.
very cool.
Cool.
So just a question for me: what do you think? What's the percentage of people or in the industry that actually do these testing kind of thing? I mean, is it widely used or is it more like now emerging?
It's emerging. It's
Yeah.
getting better because it was kind of previously it was really painful and really hard. But if you remember that in many senses, like infrastructure as a code, it could be defined as legacy code because most of the infrastructure as a code was not test covered. And if we for example take a look on the book, I don't remember author, the working with legacy code, and the main premises was make your legacy code working well. You need doing testing. So that's the step one. But it's if we look onto the generally onto the what's going around, then the coverage is getting better, but it's still a lot of room. But it is what it is. But it's getting much better, and the practices are coming into test tooling is getting better. That it's shifting more from it's already shifting more and more from just general syntax checking to also like logical testing.
That's very cool because actually, I mean, when you test for legacy code, you need other it's another premise than when you start testing from the beginning. So I assume it's going to be quite hard if we start now to test legacy infrastructure code, right? So, or is that even done, or is just like, yeah, next time we write
You
it?
just start from the one. You just start from the one like everything. Like you cannot run marathon in one day.
That's true.
Or you're gonna die, or this project will not work well. So, but you need to go step by step and start either from the easiest part or the hardest part, and step by step and achieve this. It's not like it's actually not so hard, but it's more just need it's more cultural thing than technical thing. Previously it was technical thing, and now it's much more cultural thing. And that's definitely, I think, where Valentina can help on this part.
So managers are going to be very happy with that.
Yeah, I think that this is a good topic. I mean, how to introduce it. We have similar issues even in development when you have a legacy system which was written in an untestable way, how to retroactively introduce the tests. Now, I guess the general question is, so is the conclusion currently that most people are manually testing infrastructure. For example, running Terraform scripts, and then someone is maybe manually checking like AWS Bitbucket, S3.
Yeah. Yeah, but you don't need to do any more. You can do it like in automated fashion.
Okay, so that's, I guess, the big benefit. And what is your experience if you've tried, introducing any of this into companies or teams? What's the process or like transformation pathway to get this into a company?
In the beginning, it's pretty. First of all, you need to see the benefit, like on this. It's like, and always starts with some kind of friction. When the friction is solved, that's like everybody starts seeing that there is like real benefit on really simple stuff, like for example linting code and validating code. Like you don't need to spend any more time on big cicd pipeline which fails after 25 minutes, and because you forgot to put one equal sign. But now you can get it like this part is not even working, or what I showed you with the Conftest, that like one of the coolest thing is like with Conftest you can not just take your own written policies, but you can also pull from the company, for example, company repository, like, and you can see like you are developing code like and saying, okay, we have got module with version 5, but here in code you have got version 3. You're not gonna, it's not gonna work here. So you get all the stuff much more faster, and like and that can save a lot of time, and the the main benefit for operators as DevOps engineers or developers is that you can save your valuable time on even very simple issues, and the same is goes with goes with quality. When you start testing it, you can start feeling like, oh, it actually works well, and you can say like, and you know that, and then the next step is probably real TDD, but the efficiency prism is one of the best way where to start. Even quality is even more important, but efficiency is the way how you can always bootstrap this. And plus if you work with the financial services and regulated companies, then shifting grading in the compliance into the coding infrastructure coding, it's very like cool stuff which saves a lot of time on the yearly audits and yearly all the stuff what's related to security and the compliance part.
That's a nice use case. I mean, especially how you mentioned even the example before, if there are any company-wide rules about, let's say, maybe which version of, I don't know, Java or something to be used, or if that's my understanding, those kind of checks which could then be globally.
And this you can do, and that's why this area of open policy agent is really booming currently, because it's really big pain for like compliance and security, how it's done so far. It's been very manual topic, and painfully manual. And now there is a lot of opportunities to improve this and make and shift the security practices left.
Very cool. I saw the linting, and I also think that the conf test that could actually already be done before you commit, right? mean, the next step would probably be to have some kind of plugin that you can just that runs while you code, so that you actually don't have to wait until you commit.
It's still it's very Confest and Confest itself is really on it's not logic based. It's like what you do is like you do the planning, you grab the JSONs and you parse the JSONs. It's like more or less like nice JSON parser. But so but yeah, you can. There is also pre-commit configuration for these tools. Also, you can include into your workflow. And as lately I had project where we included this into the general workflow. For example, for Docker images, when you're creating that, you cannot run your Docker image as root. You can even not build it as root. Like you cannot specify that the end user for that is root, but you have to use app user. The same was true for the Terraform code that you like, because there is a lot of, in this case there was like gazillion code of Terraform. We could enforce the same coding standards in asynchronous way.
Mm-hmm. So, Valentina, if you don't have question, we can actually look at the comments. I mean, we still have some. I think Adrian was, I think, the most interested. He wrote like 10 comments or so. So I will just start
Maybe
with
you could share them all, just so that we get the broader context.
You want to show
all, and then we'll go slowly one by one.
Formatting is just code formatting as like it just formats code in a better way. Because if you like, for example, I can show present share screen. If we will go here, for example, I don't know, let's say let's be format, Terraform format is very
you're not sharing.
Okay, just
need to edit, then I share.
Screen. Present first screen. Okay, sure. Terraform format is just like if you're lazy programmer as I, then Terraform. If I will try to do commit with the Terraform for FMT, which is basically just which will order nicer code. It's not like it's not linting, because in the end, in the back end of what is Terraform code itself, it's like it's DSL-ish representation of JSON. In the end, everything what this is like HashiCorp HCL language, but in the backend everything is basically one big JSON. And so that's why it's like just the formatting is possible, but it's not like it's not doing nothing besides improving code readability and ordering, but everything else like but if Terraform validate will do some Terraform validation and so on, and next steps what you can do, or linting and so on. It's not it's that's basically what it is.
Mm-hmm. So other thing he said, well, maybe you've mentioned this before, but these tests being run in memory, these were the Terraform tests, I think. They're all run in memory.
I will not be able to answer properly this question.
Okay.
Maybe this is a good point. I think I'm interested in also maybe doing research on that question, because that could be related to the speed factor. If
No,
it
but
could be run in memory, yeah.
With there is like why it's slower, because we are the tests what we are doing, the tests what are fast, they are done in memory. Like for example, this printing out some hello world and so on. But why they are slow? Because you have to create some semi-physical resource. Like virtual machine is like you have to create virtual machine, like assign, boot it up, and so on. There is opportunity there, if you are in AWS side, like if your main cloud provider is AWS, then you can use open source project called Local Stack, which basically starts up a local mock for AWS APIs. It's not fully like, but main APIs are there, so you can test much more faster with the virtual machine part, and so like this kind of resource you can get correct answers on the sessions. But where the thing is. When the thing you have to actually create, for example, SQL machine, it's gonna take the same, like the test's gonna take the same time what you need to create machine from CLI, test it out that thing and delete it. Like that's why these tests are much more this testing part is longer, because you have to create something virtually real.
Okay, this is a good explanation. Maybe coming back to this question about are the tests run in memory? From here we conclude that it's mixed. You mentioned some of them maybe like printing out hello world. I didn't fully get it. Is that one in memory or is it physical?
It's gonna be in memory, yeah. But
one is in memory. Okay, that one.
But when you have to create some like how much it is in IT world real resource, but when you have to create some real resource where the like network travel time to provision takes some time, that's not running. So like it's not running in memory, it's not virtual, it's goes to some real resources. Like
yeah, it's more physical. And then we also have the part in between, for example, for AWS, that someone can provision with like real physical AWS or something versus the AWS mock.
Yeah. But there is some this local stack is good way. It's not perfect, but it's a way to at least try to mock something and avoid these costs. So because like this testing, like if you the part about the infrastructure testing, like if you forget to delete your hyper cluster with 100 nodes on test, then probably you can get pretty hefty price for that but in general, yeah, like just.
So I have a really dumb question then too. So it runs all on your own machine?
No, you can integrate with your CICD flows. You can do it on of course. No, it's the same as the software testing, like code testing. You run on your machine and then you run into the shared integrated environment.
Yeah. So Adrian actually replied, so I see, that makes sense. Some tests are in memory, other things actually do not need to deploy things, virtualized, container, or physical. And then I thought the test could be set up in a way to lift all of these resources with something like local stack, so it would be in memory.
Yeah, that's if it's like it's always question about like with a test about mocking. Is it can I like if you can mock it, you can test it properly. Like you can if you can mock it, you can test it in memory. If you cannot mock it, then it takes the time or connection time. What is it? It's there.
Mm-hmm. So what else do we have? So a comment just from Daniel was, I believe that infrastructure as a code should be mandatory for every bigger projects that consist of multiple resources in the cloud. Do you think that too?
I think it's already there. Like you can the code of writing part is not any more problem. It's like there is all even like there is like one project in if I remember it was IaC, then where you can like based on ChatGPT write and generate all the infrastructure, the code, and for example for AWS there is AWS console recorder extension for Google Cloud. Oh no, sorry, for AWS for Chrome you can enable recording and it will generate all the clicks what you have done on your beloved language like Terraform, CDK, or CloudFormation.
Mm-hmm.
Code writing part is not any more problem. Like it's now we have to solve a little bit more interesting problems, not just like writing code. Like.
Mm-hmm. So I'm just interested, connected to that, would you say that then regarding Daniel's comment that all companies are already using infrastructure as code, do you see this as now being dominant or just a minority of companies who are actually doing it?
This is not like as guy who have been writing infrastructure code for more than 10 years. I like every solution have got like if you have got hammers, then every problem will be nailed, and this is like this probably will I for the new products, for the new projects, I think it's almost mandatory. I haven't seen something what is not done with some level of infrastructure as a code. The problem is not if we are talking about like big projects, then the big projects are put together from multiple vendors, and different vendors have got different understanding of the what is infrastructure as a code and so on. But I would say that 9 of 10 projects now what are happen like okay, not even 9 of 10, like let's say 95 of 100 projects what are happening are doing in with the infrastructure as a code, and it's not anymore like it's not something really specific. It's just like everybody is doing that. It's just question like, okay, we are now writing code, but we are not writing tests because we don't. And then in the end, everybody says, no, DevOps is not working, and like infrastructure as a code part is not working. But if you are not doing full software development cycle, then you are not doing full software development cycle.
Mm-hmm. It's typical. Is there actually another tool like Terraform, or is this like the industry standard?
There is multiple of them. That's Terraform is more like Terraform, and Pulumi is more like platform centric, like cloud and so on. Then there is a bunch of tools what are the server centric, like for example Ansible, best much made in heaven for virtual machine, virtual machines in cloud is probably Terraform with Ansible, or so-called Terra Ansible, and they are more popular, let's say, in sysadmin side. If for example, Pulumi does almost the same workflow and the same concepts, but you can do it in any almost any general purpose programming language, and you can use some Terraform modules. But no, like Terraform is like very easily, even it's not perfect, but it's very popular because of the consistent workflow what it gave, and the state what you have got. Like basically you have got backend database, you have got like Terraform init, Terraform plant, Terraform apply. You can see the diffs, and that's where is the I suspect the popularity, because it's simple and always the same. Even it's not perfect from syntax perspective, because DSL comes with some limitations, and yeah.
So the Terraform community is growing, I guess.
Yeah. It's growing, and there are some new parts. What's happening is this Terraform pairing, like the same approach using general purpose programming languages. But I still think it's like language is not the language is not the problem, but the testing was always the problem. Like it's not like code is not not anymore problem. Either it's DSL or it's general purpose. There is so many opportunities, but the testing is the problem. It's the problem currently.
And would you use Terraform for any kind size of system, or do you say, well, it needs to have like?
There is. It works pretty well on different size of projects. Like maybe there are some efficient ways, but from looking from availability of the knowledge and skills for people, then that this works pretty well, and there is many ways how to build it in really large projects, and really nice way. But and the people just know it because it's so simple and so logical in many senses.
So how long does it take for somebody that has not yet worked with Terraform to learn it?
If you have been doing general coding, I would say, like, if you are interested, in few days you will be pretty much will understand the concepts, and you will be like in day one you will be able already start developing, and in day 5 or let's say in 2 weeks you will be pretty efficient and pretty proficient on this.
That's good to hear that. And maybe for the audience who are listening to this, and maybe someone might be motivated after this to learn Terraform or testing, what are your suggested resources, or like where to start, or in what sequence to learn what? So should someone look at that website that you shared, or what resources do you recommend for getting started with both Terraform and testing, both for beginners and for someone who is, let's say, intermediate and advanced? What do you recommend to them for reading, learning, etc.?
I would say the official documentation. They are like HashiCorp is making money from great developer experience, so it also constitutes back to their documentation, to their tutorials and so on. That's the bread like how they become so big and so popular, do a perfect documentation, perfect developer experience. That's one of the best companies in the space from whom to learn how to do the proper devex for developers. There is a lot of there is a lot of stuff comes from a guy named Anton Babenko. He's
So
definitely
sorry, just to interrupt you, are you able to maybe just do like a minute screen share just so that you open up these websites in case people, so that everyone sees the correct spelling and stuff like that. So starting with the first HashiCorp and then later the other person that you mentioned.
Sure, screen.
Because this is recorded, and then I'm sure people will later find it useful as they are rewatching.
Just go into the Terraform and basically tutorials, all the docs tutorials, and basically you can get everything is really, really nice. And about CDK provider use, and I already told, if you want to see very good technical documentation, then HashiCorp documentation is definitely one of the best experience how to do it.
That's great.
Then weekly. I'm a big fan of this weekly TF. Big fan of their newsletter. Definitely, I suggest if you are interested in this area, then this newsletter is perfect, and I'm using on weekly basis this. And there is a lot of stuff happening, and also some telephone. And also awesome Terraform. Also great resource where to start and what to use.
Wow, this is excellent.
Mm-hmm.
Yeah, and you can get what I was talking about. Why I like this language, because it's it's a really good ecosystem around it. It's not like just tooling it. The community is big. Community is strong, and there is a lot of stuff happening. Something is dead, something is creating new, something is and it's really stable. So you can see it's it started 7 years ago and still being updated on pretty much regularly. Yep, that's definitely the starting points where you can. But as I already saw in the comments, that the hard part is not the Terraform itself. The hard part is cloud providers. This is just orchestration software, automation software. The hardest part is cloud providers itself. Yep.
Very cool. Thanks a lot, Janis. So we actually are already at the end of our session. So if you want to learn how to deliver quality software faster, just follow us on these social media. And Janis, once again, we learned a lot today. It was a very great session, very cool question and answer. And thanks a lot.
Bye-bye. Have a nice evening.
You too.
Thank you.
Thank you. Bye-bye.
Bye.